I have this desktop lamp that just died yet again, and I have this lamp for many years now, and I've replaced this fluorescent tube many times, which I'm really tired of now. So I guess it's time for an upgrade. I first started by unscrewing the base and trying to get inside of this lamp. All that is left are two wires, which we're gonna use later. The switch and the fluorescent tube fitting has to go. For the rest of all the plastic on the inside, you can just cut it away with a Dremel tool or something similar, because we need all that space. We're gonna replace the high voltage transformer with a low voltage transformer. Luckily, I have this variable transformer, which we're gonna set to 9 volts. The first circuit I've ever made was this. It's a circuit wherein one LED goes on and the other goes off, and when the capacitor is discharged and the other is then fully charged, the first turns off and the other turns on, and then the cycle repeats over and over at a specific frequency depending on these two capacitors. Now, these resistors will also determine how fast the capacitors will charge. With a couple of modifications, you can use this circuit as a pulse width modulator that uses pulse width modulation. PWM is actually a different way of controlling power to a device. Instead of restricting the power with a resistor, in which case you lose power in the form of heat, we give our load very short pulses of full power. This needs to be done at a very high frequency, because the device needs very little time to change. The reason why this works is because a human eye cannot detect these high frequencies, in which case we're going to use as a dimmer for a lamp. Otherwise, all you see is just a blinking LED. The width of each pulse on and each pulse off will determine the average voltage. Just take your input voltage, divide it by 100 and multiply the width in percentage it is turned on. So if I have a 9 volt input and the width of the duty cycle is 30% on and so it is 70% off, my average voltage will be 2.7. So our load will behave like it's getting a 2.7 volt. Alright, let's modify this circuit. We don't need these LEDs, so let's just get rid of them. Next, as I said, these resistors will also determine how fast the capacitors will charge. So let's add a 50K potentiometer. And let's make these capacitors turn from 220 microfarad to 10 nanofarad to increase the frequency. To make the circuit suitable for delivering some more current, just use a MOSFET like this. Now, with a potentiometer, if we turn left, the left capacitor can charge very quickly and the other more slowly, and if we turn right, the opposite will happen. Alright, here's my final circuit design for our desktop lamp. Here are my 5 LEDs and a resistor as a current limiter and my MOSFET. Be sure to connect the gate, the drain and the source correctly. So let's build this first on the breadboard to check if everything works. Here it is on the breadboard and looks like everything is working fine. If I connect my oscilloscope probes to the output, I get this square wave just as we wanted. With the potentiometer, I can control the duty cycle. Let's make this a bit more permanent to solder this to a piece of perf board. I used 5 10mm super bright LED, which I hot glued in place on a piece of plastic I just had laying around, and connect them all in parallel. The reflecting material on the back is also a conductor, so to prevent any short circuit with that, I just covered it up with some tape. I soldered some wires to the LEDs and glued the LED strip into place. And remember those wires we have left? Those are our power cables now, in which case we're gonna connect our transformer to the circuit board. I used the hole where the switch used to be now for our potentiometer. Once everything was finished, I closed the case up, added a knob for the potentiometer and gave it a try. Well, there you go. That's how you can upgrade a desktop lamp with LEDs, and with a super efficient technique of controlling power. So now you know that this technique is awesome, you shouldn't power everything with PWM. You don't want to power a microcontroller with this PWM AC power source, because they just need pure DC. In the future, I will demonstrate how to make a power supply that uses PWM and still spits out a DC voltage. Just one last thing. Your eyes may don't see any kind of blinking on these LEDs, but cameras sometimes do respond and they gave these weird moving lines, what you probably don't want if you're shooting video. But that's it for this video, thanks for watching.